Okay. So it says Marco can build a laptop twice as fast as Cliff. So we got Marco and Cliff in third period. We had a whole off-topic conversation about Clifford the Big Red Dog. Was anyone like really big on those books? Nobody? Yeah. I used to love those books. Working together, it takes them 5 hours. So I gotta do them together too. Okay. So for together, so this is a little bit backwards because normally we would have actual numbers for each individual person, and then the together part is where we have the variable, and this time it's the opposite. So together we know that it's 5 hours. And then for them, it says that Marco is twice as fast as Cliff. And what I've noticed, and this could be just about me personally, and maybe it's not true for you guys, is that when they say things like twice as fast, I always get confused about like who is X and who is 2X. Like I have a hard time figuring that out. So for me, the easiest thing to do is to assign a number to one person, like the numbers to two people, and then I go back and replace it with X. Okay? So if Marco is twice as fast as Cliff, then that means he can do it in less time. Would you guys agree? He's twice as fast as Cliff? Okay. So somebody throw out a number that isn't like 2 or 4 or something like that. Somebody throw out a number that we could use. So just throw out a number. 30. Okay. So we're going to say Marco takes 30 hours. So we do like 1 over 30. And we're going to erase this in a second because we're going to have to put an X in there because we don't actually know how long it takes him. But we'll say it's 1 over 30. So he is twice as fast as Cliff. So if he takes 30 hours, then how long would it take Cliff? 60 hours, okay, because he's twice as fast as Cliff. So 1 over 60 is what Cliff would be. Now, because we don't actually know how fast they are, we have to put the X's in there. So that means that Marco would be 1 over X, and Cliff, because he's twice as fast, right? So Marco would be the 1 over X, and then what would Cliff be? 1 over 2X. So even though Marco is the one who's twice as fast, Cliff is the one who gets the 2. Does that make sense? And sometimes it's a little bit easier to see that if you just plug numbers in. Because for us, numbers feel a little bit more intuitive. Variables do not. Make sense? Okay. So we've got Marco is 1 over X. Cliff is 1 over 2X. And then it says together they can build the laptop in 5 hours. So what should our equation be? Okay, 1 over X plus 1 over 2X equals 1 over 5. All right? And then what should we do? 10x, yeah, 10x would be the common denominator. So if 10x is the common denominator, we can take the entire equation and just multiply by 10x. So since these are much simpler rational equations than we did when we were learning how to solve rational equations, you might have gotten to the point where you don't need to show as much work. And if you don't need to show as much work, that's fine. So, but if you do want to show all the work, you can. So 1 over x times 10x plus 1 over 2x times 10x, oops, x, equals 1 over 5 times 10x. So I'm going to go ahead and show my work for every single little step. Okay, so for the first term, 1 over x times 10x is 10, yeah. I think people are just whispering behind their masks. And then 1 over 2x times 10x, 5. And then 1 over 5 times 10x, Okay. And so we have 15 equals 2x. And then what do we get for x? X equals 7.5. And so our conclusion, how long would it have taken Marco alone? What's our conclusion? 7.5 hours. So we're definitely going to put units on there. I'm not going to make you write sentences today, but if we were a testing situation and it said write the answers in context, we could write a sentence if we needed to. Okay. Yes. If it had said what? Yes. If it had asked about Cliff, we would have just taken that and said 15. Multiply by 2. Yep. Okay, go ahead and turn to the next page. So I did kind of a little reminder about this with the varies inversely, and then decided not to do any more with this because the varies inversely really is more part of the Math 2 curriculum versus the Math 3. So the bottom two examples, you can just put an X through. We're not going to do those because those really align more with the Math 2 curriculum. So we are going to skip those. Go ahead and turn to the next page. That should be all filled out. There is kind of a typo on here. I don't know how closely you looked at it, but when you move upstream, the current moves against you. And when you move downstream, the current moves with you. I typed it backwards. Third period made sure that I knew that I was wrong. So, and I said, whoa, I don't go fishing. No, apparently those were right. Those make sense. Yeah, because it would be how still it is, and then the rate of the still water subtracting off the speed of the current still makes sense. Because how fast you're moving would be slowed down by the current. So that, or how fast you're moving would be sped up by the current. So that is still making sense. Yeah, it was just my wording was switched. Okay, go ahead and turn to the back page. We're going to go ahead and do the last two examples. When I made the notes, I didn't pay attention. I just copy pasted the table and I didn't pay attention to the examples. So it says upstream, downstream, but we're talking about a plane, which obviously doesn't have an upstream, downstream. So in this context, we have the plane flying with the wind or against the wind. So we're going to scribble these out because this is not true in the context of the problem. And we're just going to say with the wind and against the wind. So we are still going to use X for the speed in still air. And then we'll go ahead and use W for the speed of the wind. Instead of using C for the current. Okay, so it says a plane flies 910 miles with the wind. At the same time, it can go 660 miles against the wind. So 910 miles with the wind. At the same time, it can go 660 miles against the wind. The speed of the plane in still air is 305 miles per hour. What is the speed of the wind? So we're going to say still air with the wind, so plus the wind with the wind, still air against the wind. Okay. And then if we know that if distance equals rate times time, then time is going to equal distance divided by rate. And so we can do 910 divided by 305 plus W, and then 660 equals 305 minus W. And these they make intuitive sense, like common sense, because this is the bigger number and it goes with the plus W because the wind helped it to go faster. This is the smaller and it goes with the smaller number because the wind made it go slower. Does that make sense? So it didn't get to go as far in the same amount of time. Okay, yes. Which one is it? These are, this is what I have? Say it again. This is what we had from last night.
Yeah, I was just confused why last night we did like subtracting the number for the rate of stream, but
Oh, I marked backwards. This is because this is a plane. So we're just changing it for with the wind versus against the wind, and I happen to put with on top. Does that make sense? So whichever one you label is like they're interchangeable. So you could put plus C on the top and minus, you could put like downstream on top and upstream on bottom, and it doesn't really matter as long as you keep in track as long as you keep track of what they mean. So if you put upstream on the bottom, just keep track of upstream means that I'm going against the current, that the current is fighting me and it's going to slow me down. And you can always tell that because that number is going to be smaller. I will have had the same amount of time, but I won't go as far because I'm fighting against resistance. And so you can see the speed I was going in the stillness, right? And then minus the wind because the wind is hurting me. It's keeping me from going as fast. Does that make sense? So here I just, upstream would have been the one that makes it harder to go, but I put against the wind down here. So I ended up with the plane example. I kind of did it backwards when I wrote down which words. Yeah, that's why they're opposite with the plus and the minus. Yeah. Sorry, I thought you meant the numbers, the big and small, were backwards. And I was like, oh no, I did something wrong. Yeah, I just did my words backwards on this one. Okay. Are we comfortable so far with the examples? We're good with that? Okay. Now, when it says at the same time that it can go, that's the reason that we're able to set these two equal to each other because it's saying that you can go those two distances in the same amount of time. So that's why we're able to take these two things and set them equal to each other, is because that wording is telling us that those two things are equal. That's what makes this as an equation. So we're going to say 910 over 305 plus W equals 660 over 305 minus W. And then what do we do next? Cross multiply. Okay, perfect. So we're going to do these two together. So 660 times 305 plus W, and 910 times 305 minus W. And what should we do with this? How do we get rid of the parentheses? Distribute. Now we want to get the W's to one side. And then get the numbers to the other side. So the speed of the wind is 48.567 miles per hour. Okay. Does that make sense? We're okay? All right. Okay. Look at the next problem and see if you are able to fill out the table. So instead of upstream, downstream, we have upriver, downriver, but it's the same idea. A person swims 11 miles downriver in the same time. They can swim 7 miles upriver. The speed of the current is 4 miles per hour. Find the speed of the person in still water. So it's a little different. You're solving for still water instead of solving for the current. So keep that in mind. So we got 7 miles upriver, 11 miles downriver. The current is the 4 miles, so that's the second number, not the first number. So that's a little different from the other examples. And then for time, we've got distance divided by rate. It still says in the same time. So we can do equal sign, right? They're going to equal each other. Oh, I wrote 7, I meant 11. All right, did you guys get the same thing? Yes. Okay, and then what are the units? miles per hour. Okay. All right, so the worksheet that I have for you today, another teacher made it. I just printed it off, and so there is no room to do your work on the worksheet, like hardly any. You have to have a very small handwriting, like very, very tiny font. And I was also afraid to to do like hole punch it because the margins are really small and I didn't want to cut off any of the numbers. So I'm just going to hand it out, and you can do it on a separate sheet of paper. And then if you want to recycle this, that's fine. And we're not gonna do all the problems, so I'm gonna tell you guys which ones to skip after I hand it out so that you can write on it. Somebody answer that for me. I know. Okay, so Eleanor, before you leave, we're gonna skip 11 through 15. So, did I give you one? Yeah. 11 through 15, we're gonna skip. 11 through 15, we skip. Okay? We're not doing these together where you guys are just working your tables. So the notebook paper on the back wall, if you can see it, that's the answer key, because the answer key does not look like this. So the notebook paper that's back there. There's no video tonight because this is our last day of learning. So tomorrow is the test review. Thursday's the test. Just a heads up. Tomorrow's test review, Thursday's test. So just so you guys know what is coming, we are at the end of the unit. All right. You are fails in those. Those are for you guys. Okay. Yes.